Hello, hello, hello. I hope everyone can hear me. My computer had a little hiccup, but should be working fine now. And I'm just going to wait for everybody to join the session and start at 7 p.m. sharp. But for those of you who've joined already, welcome to Save the Med live lessons. My name is Jasmine, and maybe not. I'm just going to wait a few more minutes. I hope there's no technical difficulty. Welcome to the live lessons. My name is Jasmine, and I'm the Expeditions Coordinator at Save the Med Foundation. We ship is plastic pollution, and we also measure the presence of microplastics. And that's what I'm going to be talking about today. So I'm going to start with a really simple introduction to what a microplastic is. It's just a plastic fragment that's less than 5 millimeters in length. So if anyone's recently been to the beach or has come across these fragments washed up on the sand, you've probably seen it before. But why talk about microplastics and why study microplastics? Well, the very simple answer to that is that they're everywhere. They have been measured found in the Arctic, in the deep sea, in the surface of the ocean, in our food. They really are getting everywhere, even in the air. Where else can we find them? Where do they come from? So what is the source of most of these microplastics? And by knowing the source, you can start. And also, how are they impacting human health? Now, there's not a lot of studies that's actually been done about the effects of microplastic on human health. It's just starting, it's just an emerging field. But in the future, I believe that there's going to be more studies done about this because we're seeing so much microplastic in our water systems and in our ecosystems. So the next part of my talk, I'm just going to go through 5 microplastic myths and facts. And I'm going to start with the first one. I made a little sheet here. And the first one is microplastics are a new thing. So this is kind of already a trick question. They're only recently have been studied by a lot of scientists, and a lot of papers have been written on them, because only for about a decade, scientists have really been starting to pay attention of microplastics. But we've known about them for a while, and they were first discovered in biologists' nets and samples back in the 1960s and 70s. But as I said, only recently we've started really paying attention. I first actually encountered the whole concept of microplastics in 2014 when I joined an expedition into the North Atlantic Gyre. And the purpose of the expedition was to actually see what the impact of microplastics was on marine life, on tiny marine life, little plankton. And we sailed out to one of the gyres. Now, for those of you who don't know what a gyre is, it's just a huge oceanic surface current that rotates. And there's about 5 main gyres in our oceans, and they tend to accumulate floating debris, plastic, and microplastics. So they're kind of like accumulation zones for microplastics. And on this expedition, we were going to sail right into one of those gyres, the North Atlantic gyres, between the Canaries and the Azores Islands in the North Atlantic. And I was kind of peering my head out of the sailboat and looking for this giant island of floating trash that I'd read about and heard about. But that's not quite what I found when I was out there. What we saw is that most of the plastic out in these areas is just invisible. So we dipped our nets underwater and found that a lot of it was more of a kind of microplastic or plastic soup or smog rather than a giant floating island, because this plastic had degraded into smaller bits. And so that's already one misconception that's actually around there, is that there are these big islands of floating plastic. But what happens is that plastic actually over time does degrade, and it's more unseen And a lot of the plastic is just below the surface, floating around as microplastic. So there are 5 main oceanic gyres, and these are the areas where a lot of plastic accumulates. So it's a good area to go study plastic. But today I actually want to focus on the Mediterranean Sea, which has now been measured as one of the areas with the highest average density of microplastic particles in the world. So the little old Mediterranean Sea is only 1% of the world's water, but it actually concentrates 7% of all global microplastics, and is actually considered one of the greatest accumulation zones for marine litter. So why is there so much plastic in the Mediterranean and so much microplastic? I'm not 100% sure of the answer, but there are some things that can lead us to think why. For example, it's a closed basin, first of all, and it has a very large population density of humans. And wherever there's humans, there's mismanaged waste. And where there's mismanaged waste, there's plastic debris flowing into our waterways, into our ocean, and eventually microplastics. But where does all this microplastic come from? So that's my second question. Where does it really all come from? What are microplastics originally made of? And it's not as obvious as you might think. There are 2 types of microplastics. There are primary microplastics and secondary microplastics. Now, primary microplastics are actually plastics that were already tiny before they entered the environment. So things like microbeads that are put in exfoliating creams and glitter. Glitter is engineered already to be tiny, so don't be fooled by glitter. It's just a shiny, dressed up version of microplastic pollution. But I made a little pie chart for you showing actually the main sources of primary microplastic. And the 3 big ones are not what you expect. One of them is city dust, which is actually microplastic in the air. So microplastic that kind of rubs off of our shoes or our clothes or any objects that are around us and is kind of hanging about in the air. Another big source of primary microplastic pollution are tires. So the tires of our trucks and our cars that erode while they're driving on the road, and then all this with rain gets washed into our waterways and into the ocean. And one of the very, very big perpetrators, it's actually the biggest percentage, is textiles, so synthetic textiles, so our clothes. So a lot of clothes today are actually made of plastic. They're made of polymer material. And this is an interesting one because it's actually something that we can help to reduce immediately by buying less synthetic fibers and going for more natural fibers like cotton. But also, if you already have a lot of synthetic clothing, you can use guppy bags, put your clothes in a bag when you wash them. And the reason you do that is because a lot of the microfibers from your clothes are released into our oceans while we wash them. So hundreds of thousands of fibers actually come off our clothes every time we wash a synthetic fiber. Another solution would be to wash your clothes less, which maybe sounds a bit dirty at first, but actually your clothes don't need to be washed as many times as you think they do. So there could be a whole other 20-minute talk just about this, but I'm going to move on to secondary microplastics. Now, secondary microplastics are actually the most common microplastics found in our oceans and our seas. They're about 70%, and these are coming from larger pieces of plastic. So these are plastics that used to be something bigger, but then over time, with the action of waves, sunlight, and sometimes even microbes, break down into smaller and smaller fragments. So that could have been an old flip-flop, your candy wrapper, a piece of Lego, old cigarette butts, a plastic bag, bottle caps. You get the picture. A lot of it is also coming from abandoned fishing gear. That's a huge source of microplastics in our ocean. And what happens is, obviously, the plastic degrades into smaller pieces once it's in the sea, and things like temperature really speed up the process of degradation. So when you say plastic lasts forever, um, it might not seem so at the beginning, but if you think about it, these plastic objects, are not decomposing or biodegrading. They're just fragmenting into smaller and smaller pieces, but these pieces are still plastic. They're still made of plastic, and they can become tiny. And scientists are now starting to study nanoplastics that are only a few micrometers in size. So it kind of does last forever, but maybe not in the form that you originally thought it was. Um, so this leads me on to my next question or fact. Microplastics are tiny and therefore not dangerous. This is not true at all. If the coronavirus outbreak taught us anything at all, it's that tiny things can cause a lot of damage. So the small size of microplastic not only makes them really, really hard to clean up or practically impossible, but it also means that it becomes bioavailable and is mistaken for food and therefore enters our food chain. So a lot of small fish, juvenile fish, plankton, tiny shrimp are eating this plastic. And this is a picture of a tiny little shrimp that has plastic in its intestinal system. Now, this is on a laboratory condition so that you can see the plastic glowing. Now, the problem with this is, well, there's a lot of problems with obviously eating a bunch of plastic. One of them being that this little plankton probably won't eat a lot of food in a day. So when it does eat plastic, it doesn't have room for anything else. And this can seriously deprive them of energy and cause a lot of damage. And these small changes to small species like this can have a big knock-on effect to larger species across the food chain. For example, plankton are the main source of food for whales. But one of the actual big worries when it comes to microplastic particles is actually its toxicity. So plastic in itself, plastic products, a lot of times, plastic producers use things like plasticizers, dyes, and additives to give them certain properties that we expect out of plastics. So one example of these kind of compounds that they use are called phthalates. I don't know if I'm pronouncing it right. And they kind of look like this, and they're put, if you imagine these little spaghettis to be plastic polymers, you put them in between, and it gives it a lot of flexibility because the big, long molecules are therefore able to move and they're not all squished together. And phthalates are found in quite a lot of different types of plastic, like PVC, but they can also leach out of the plastic. And this also can cause damages to marine wildlife. Another thing about microplastics is that, yes, they contain a lot of toxic chemicals, but they actually have an ability to absorb and concentrate toxic chemicals from the environment around them. So in the ocean, you have quite a lot of environmental pollutants called persistent organic pollutants. And they're called that way because they are persistent. They are chemicals like PCBs or DDTs and dioxins that were used in agriculture and in flame retardants. Some of them have been banned, but they're still found in the environment, and they still persist in our aquatic environment. So these chemicals, along with phthalates, are quite nasty. They are linked to hormonal disruption, developmental problems, and especially in pregnancy and even cancer. So you don't want to be messing around with them too much. But what microplastics do is they're a perfect vector for these chemicals. They actually absorb them like a sponge. So when they're eaten by small animals like plankton, they can easily accumulate up the food chain into bigger and bigger fish in a process called bioaccumulation. So large predators eventually tend to have a lot of these chemicals in them. So if you think of it in in another way, one tiny piece of microplastic can be 1 million times more toxic than the water around it, than the ocean water around it. And in areas like the Mediterranean, with high levels of microplastic, this really can affect the wildlife, like cetaceans, dolphins, and fin whales have been found with very high levels of phthalates in their tissues. And a lot of the females also tend to pass these toxins on to their calves, reducing their chances of survival. So the toxins pass through to the calf milk. And a lot of the first calves of cetaceans don't survive because the milk is so toxic. And of course, microplastic has been found in humans as well. So we're eating it, but not only if we eat fish, it's been found in our drinking water. And I think a recent study in Austria, not so recent, but relatively recent study in Austria has found microplastic in human poo. And that is absolute proof that it's being eaten. That it's now part of our food chain. So even though microplastics are small, they really do pack a punch. And this is leading me to one of my final questions. All microplastics float. So I'll go through this one quite quickly because there's not a lot of time left. But basically, what happens to microplastics when they're in the sea? Do they all just float in the water? Not really. 3 main things can happen to them in the water. It either floats on the surface and goes through oceanic currents, or it sinks to the sea floor. So not all microplastic floats. Some of it is buoyant, and it depends on the type of plastic, and some of it sinks to the bottom of the ocean. The other thing that can happen to it is that it gets eaten by an animal, which is the fate of a lot of plastic. And the fourth thing, actually, that can happen is that it gets picked up by a scientist and studied, which leads me on to my final question. How do we study microplastics? Well, on board our ship at Save the Med Foundation, we have a research vessel, Toftevag, and we actually take microplastic samples at sea in something called a manta trawl, which looks something like this. It looks like a manta. It's on the surface of the water, and it has a net that filters plastic. And we just put it in the water for about 30 minutes at a time, and it filters, and we then pull it up and have our microplastic sample ready to analyze on the ship. This manta trawl we have on board was actually sent to us by 5 Gyres Institute, and they have a trawl sharing program where they sent trawls to citizens and scientists around the world with a standardized protocol to analyze microplastics so that they can have a global estimate of microplastics around the world. And when we record things like we record the latitude, the longitude, and the depth, and we also we put the microplastics into 5 different categories, which are fragment, foam, pellet, line, and film. So a film would be like a candy wrapper or a cigarette pack wrapper, and a line is usually from a fishing line or from your clothing. And these are things we can actually identify on the ship using our eyes. We don't need a microscope, and we can easily categorize them into these 5 categories. And once we've done that, we actually send the information to the global database so that it's included into that global estimate. And this gives you a very general idea of what kind of microplastics are at the surface of the water. Of course, there's a limitation because we're not studying microplastics at the bottom of the ocean or in the middle of the sea, but there are other research teams that are doing that as well. And I see I'm running out of time, but I have one more thing to add, which is a method called spectroscopy that's used to analyze microplastics. So if you have a well-equipped lab, you can actually use Fourier transform perform infrared spectroscopy to find out exactly what kind of polymer it is, because a lot of these microplastics, we don't know what they used to be before. Some of them we do, but some of them it's really difficult to know. So using infrared spectroscopy, we don't use it ourselves, but a lot of labs do. You can actually find out all the different what kind of polymer it used to be, and from there try and make a guess of what the object used to be before. And yeah, I think that's about all we have time for today. I do want to kind of go on, but I think that I'm going to get in trouble if I do. But I'm going to take some questions now because it's question time. So, oh gosh, there are so many. Let's see, any questions? Natural fiber alternatives in outdoor clothing. Oof, that's a really good question. I don't. That's a good question because you want outdoor clothing to have the properties of synthetic fiber. I mean, wool is always great. It's not good when it gets wet, but if you're going outdoor, it does have properties that allow you to stay cool, but also warm at the same time. And let's see if there's any other questions. I know there's what interests me is actually there are a lot of labs that are really, one of the ones that came up in my news feed the other day was a kind of fiber made from squid protein that was really weird, but I thought was also very interesting. They genetically engineered some squid protein into some E. coli, which produced a squid fiber, which they then spun into a fiber. And this is obviously all in the laboratory, but I thought it was cool. And I think these are the kind of things that might lead us to maybe some more interesting and less toxic brands of clothing in the future. If anyone is more interested in exactly how this squid fiber is produced, it's called Squitex, which is a strange name, but it kind of works. Let's see. Are there any more questions from the team? Where do the big plastic present in the gyre's parts come from? Oh, so this is a good question. So like where does all the plastic come from in the first place? Well, that's another 20-minute talk, but I mean, it's all mismanaged waste. So it's objects that are supposed to be disposed of. They're supposed to be disposed of either through recycling or going to the correct waste facility, but they're not. They're either lost or blown away in the wind or purposely discarded into the sea. And since we're on the topic, one thing I didn't mention is that one of the most important things, obviously, is to look at how we can reduce the amount of plastic that is ending up in oceans, and that's how you can reduce microplastics. So there are so many ways to do it. We use 4 R's. We're refuse any plastic that is, at the shops. Refuse a plastic bag. Bring your own bag. Reduce your overconsumption by only buying what you really, really need, and reuse things as much as you can, and recycle if there's no better option. But if you want to go more in depth with this, if you look at the links below, I've linked to Save the Meds plastic programs. We have a lot of programs that are helping with the reduction of plastic by, firstly, education. So we have a Dos Manos program, and we just put all our stuff online as well, which is great. So if you click on the link below, you'll see. And also a plastic-free Balearic program where part of our team is working with businesses to help them reduce their everyday consumption of plastic by providing alternatives. And maybe one day they'll give another talk just about different ways which we can reduce our plastic and reduce the microplastic in our environment. And yeah, and this talk is a new thing for us, but we're going to do more. And the next one is going to be on Friday with Biel, who is our shark expert and co-founder at Save the Med Foundation. The talk is going to be in Spanish, but we have other English ones coming up if you don't speak Spanish. So definitely keep an eye out on our Facebook and Instagram, because we're going to be posting more. And if there's a topic that you're particularly interested in, just write a question, write it in our comments section, and we'll take it into account. Obviously ocean related or Mediterranean Sea related. But yeah. And I have a good question. Everyone assumes plastic comes from third world countries. Is that true? Yes, this is a very good question. And the question is no. The answer is no, it's not true. It comes from all of us, everywhere, all the time. And that's why the reduction starts with each and every one of us, and especially developed countries are massive consumers of plastic. And it just shows, the Mediterranean is one of the most polluted places in terms of microplastic, and it's a lot of developed countries and not third world countries that are throwing plastic into the ocean. So yes, it's all of us, really. And I think I'm going to do one more question, and then I'm going to leave you. Can anyone? Let me see. Let's see. I have a question. Would you be interested in manta toe samples from different areas in the Med? Oh, wow. Marine research expeditions. Yes, absolutely. Let's stay in touch. Let's stay in contact. Our plastics are our samples are only in the Balearic Sea, so it'd be very interesting to see what's going on in other areas of the Med. And then one more question. All right, and then I'm done. Would the single-use plastic ban in the Balearic solve the plastic issue significantly? Well, it would definitely help, but people would have to actually take heed of it, and actually not use plastic. Because one thing is putting a ban in place, but if people still continuously use plastic, then it would have to be enforced, basically. And if it's enforced, it would solve it would really, really, really reduce a lot of plastic in the oceans, because a lot of the plastic we see are single-use objects, so things that you use just once and throw away. So it would be a huge help. And with that, I think I'm going to leave you all. Remember to let us know if you have any suggestions for new talks. And let us know if you like this one, and see you next time. Bye, everyone.